Have you ever had one of those really specific quiet nights?
Oh, yeah, where you're just lying awake.
Exactly. You're lying in bed, you're staring up at the ceiling, the house is completely still,
Right.
and out of nowhere, your brain just hits you with this ultimate heavy-hitting existential question, like, why are we here?
Yeah, the classic midnight crisis.
Right. And not just you personally, but why is there anything at all? Like, why does a universe exist rather than just, an infinite void of nothingness?
It's a terrifying thought if you actually sit with it.
It really is. But usually you might ponder that for about 3 minutes, feel a mild sense of vertigo, and then you remember you have an early meeting.
Or you need to buy groceries.
Yeah, exactly. You
Doesn't-
just push the thought aside to deal with the reality of your daily life. But what if you didn't?
Right.
What if it was your actual, literal profession to never set that question down?
Well, I mean, that requires a profound shift in perspective. You're taking the ultimate philosophical mystery, the absolute boundary of human comprehension, and treating it as a tangible puzzle.
A puzzle meant to be actively solved. And that is the exact premise of the source material we are looking at today.
Yeah, the Tenerife Congress.
Exactly. A group of the world's most brilliant physicists, cosmologists, and philosophers gathered recently from September 13th to the 16th. This was at the Philosophy of Cosmology Congress held in Tenerife.
And the report from those rooms is just staggering.
It really is. The mission for our deep dive today is to explore those absolute boundaries of science. We want to find out if physics can actually solve this fundamental mystery of existence, or if our own human perception is permanently getting in the way.
Which is a very real possibility.
Okay, let's unpack this. Because right out of the gate, there's this insurmountable divide among the smartest people on Earth.
Right.
They're arguing over whether science is even allowed to ask this question in the first place.
Yeah, the foundational debate at the Congress wasn't actually about the answer to the universe's origins.
Wait, really? Then what was it about?
It was about the validity of the question itself. On one side of this divide, you have a fiercely optimistic camp.
Okay. Who's in that camp?
People like Rafael Rebolo, the director of the Canary Islands Institute of Astrophysics, and Carlo Rovelli, a renowned quantum gravity expert.
Oh, Ravelli. He's a big deal.
Huge deal. And their stance is highly proactive, like almost bordering on defiant. Rebolo argues unequivocally that there are simply no forbidden questions in science.
None at all.
None. And Rovelli pushes that even further. He insists that scientists have a fundamental duty to be brave and, in his exact words, to try everything.
So they're essentially taking the stance that no mystery, no matter how ancient or existential, is immune to the scientific method.
Exactly. They think we can crack it.
But then the skeptics step in, and we should note, these aren't just fringe critics.
No, not at all. We are talking about historical heavyweights here.
Like Jim Holt, he's the author of the essay Why the World Exists, and he points out that a significant portion of mainstream physicists actually reject the idea that physics can completely solve this.
Yeah, Holt notes that for many working scientists, asking why something exists rather than how it functions is essentially a nonsense question.
Like a category error.
Exactly. A category error they believe should be left entirely to theologians or mystics.
And he aligns that argument with some really influential scientists, too.
He does. He points to figures like the late Steven Weinberg.
Nobel laureate Steven Weinberg.
Right, Nobel laureate in physics, author of the seminal book, The First 3 Minutes. Weinberg's position was incredibly nuanced.
How so?
Well, he firmly believed that why are we here is a deeply serious, valid question. But crucially, he believed it's a question that the machinery of science fundamentally cannot answer.
Okay, and Holt adds a compelling layer of logic to this limitation, focusing on the problem of infinite regress.
Right, the infinite regress.
Which is just the idea that every answer spawns a bigger question. Like,
Yeah.
even if we somehow developed a flawless scientific theory.
Like a perfect mathematical model of quantum gravity.
Yeah. Let's say we have a perfect model that elegantly explains how matter can spontaneously erupt out of a true vacuum. You solve the how.
But instantly, you hit a new wall.
Exactly. You then have to explain why that specific mathematical framework is the one that dictates reality and not some completely different set of rules.
You haven't solved the mystery of existence.
No, you've just pushed the mystery one step further down the road.
You end up having to explain the origin of the laws of physics themselves.
Which is mind-bending.
It is. And this brings us to a really practical, physical roadblock that was introduced at the Congress by George Ellis.
He's the cosmologist from the University of Cape Town, right?
Yes. We can conceptualize his point as the unattainable data problem.
Okay, what does that mean?
Well, to figure out why life exists, or why the universe exists, the standard scientific method dictates that you need a control group.
Sure, you can get something to compare it to.
Right. You need to observe the absence of a universe in a sterile, isolated environment to compare against the universe we actually have.
But how do you search for, let alone measure, absolute non-existence?
You can't. That's Ellis's whole point. He's stating that theories about the universe's ultimate origin inherently go beyond the limits of science because we only have one universe.
We are trapped inside a sample size of exactly one.
Exactly one, which forces a harsh reevaluation of what actually constitutes rigorous science. And for context here, Ellis is a Templeton Prize laureate.
Oh, that's interesting because the John Templeton Foundation actually funded this entire Tenerife conference, didn't they?
They did. They funded it specifically to advance research concerning spiritual and ultimate reality.
That's a fascinating overlap.
It really is. Ellis and the conference co-organizer, British mathematician John Barrow, represent this unique intersection where hard empirical science collides with ultimate philosophical meaning.
Right.
And Ellis's point is just devastatingly simple. Science, by definition, requires empirical testing and falsifiability.
You have to be able to prove it wrong.
Right. You can build the most elegant, mathematically perfect theory about the universe's origin in human history. But without comparative data,
Without a second universe.
or a state of non-existence,
Yeah.
to measure it against, it remains permanently untestable.
I mean, I get that,
Yeah.
but I want to push back on this limitation, though.
Okay, go for it.
Let's look at the logic of deduction. Imagine you want to understand the overarching fundamental rules of all sports ever invented,
Okay.
but you have only ever been allowed to watch half an inning of a single baseball game.
That's a very limited data set.
Yes, it is incredibly limited, but isn't the whole point of theoretical physics to mathematically imagine what we can't physically see?
Sure.
Like, by closely observing that half inning of baseball, a brilliant mind could deduce the laws of gravity, the physics of projectile motion, human biomechanics. They could deduce universal rules from a localized event.
That's a fair point.
Yeah.
You can certainly deduce gravity and biomechanics, but here is the philosophical boundary Ellis is pointing out. You cannot deduce if baseball is the only sport that exists.
Oh, I see.
Right. Without ever seeing a basketball court or a swimming pool or a soccer pitch, your deductions will be entirely constrained by the parameters of the baseball diamond.
You might mathematically formulate that every physical action in existence must inherently involve a wooden bat and a leather ball.
Exactly. You can write a beautiful model for how sports work, but without stepping outside the stadium, you'll falsely assume the local rules of your specific game apply to all of existence.
Wow. That is a staggering limitation. We are entirely trapped inside the experiment, mistaking the local weather for the global climate.
It's a sobering thought.
But if Ellis is right, and we are permanently trapped inside a single universe without a control group, that puts an immense amount of pressure on the only tool we have left, which is human perception.
Yeah, it does.
But how reliable is that perception? I mean, the lack of comparative data doesn't necessarily mean we should just abandon the pursuit, right?
No, not at all.
Because history proves that our intuition, our very ability to perceive the fabric of reality, is constantly undergoing radical upgrades.
Oh, absolutely. The historical timeline provides a powerful counterweight to the pessimism of the unattainable data problem.
Yeah, let's talk about that.
Well, consider the boundaries of human perception just 1 century ago. To the greatest scientific minds on Earth at the time, the entire known universe consisted solely of the Milky Way galaxy.
That was it. That was the whole universe.
That was it. Furthermore, we only observed it in the narrow band of visible light. There were no infrared sensors piercing through cosmic dust.
No radio telescopes listening to the echo of the Big Bang.
Exactly.
Yeah.
And certainly no X-ray or gamma-ray observatories in orbit. Our entire conception of reality was strictly bound by what our biological eyes could process, aided by some relatively primitive glass optics.
And then the upgrades arrived in a torrent.
They really did.
Not from biological evolution, but from the sheer force of theoretical physics. Specifically, theories like relativity and quantum mechanics.
Right, which fundamentally changed everything.
They unveiled hidden, profound realities that our natural biological senses could never have detected. Like, Einstein showed us that time isn't just a ticking clock in the background.
No, time literally stretches and compresses depending on the speed and gravitational position of the observer.
Which is insane to think about. And then quantum mechanics revealed superposition, demonstrating that at subatomic scales, a particle can quite literally occupy two distinct locations simultaneously.
We could not biologically see or feel these phenomena.
Right, but the mathematical scaffolding of science built a reliable bridge to them.
Which brings the discussion at the Congress to one of the most compelling and honestly frustrating modern mysteries,
Yeah.
dark energy.
Oh, dark energy.
According to our current standard model of cosmology, dark energy makes up roughly 68% of the entire universe.
68%.
Over 2/3 of everything. We observe its effect, right? It's the theorized engine causing the expansion of the universe to accelerate rather than slow down.
But beyond its accelerating effect, the scientific community knows absolutely nothing about its fundamental nature.
Nothing. It is a staggering, invisible variable dominating the cosmic equation.
Just to ground this in everyday experience for you listening right now, think about the room you are sitting in. If the standard model is correct, dark energy makes up nearly 70% of all reality.
Yeah.
That implies it could be right next to you, completely permeating the space around your body, and you are totally oblivious to its presence.
Completely undetectable to your physical senses.
Yet it dictates the ultimate fate of the cosmos.
It really highlights the severe limitations of our sensory equipment.
It does.
However, at the conference, Ofer Lahav,
The astrophysicist from University College London.
yes, he offered a highly compelling alternative perspective. He challenged the default assumption that dark energy is necessarily some exotic, invisible substance hovering in the void around us.
Okay, what was his theory?
Well, he suggested that the observed accelerated expansion of the universe might simply indicate a flaw in our understanding of gravity at macro scales.
Meaning we wouldn't need to invent a mysterious new invisible energy to balance the math.
Precisely. Lahav's argument focuses on the mechanism of gravity itself.
How so?
If gravity behaves differently across billions of light years than it does within the relatively tiny confines of our local solar system,
So if its foundational behavior changes at cosmic scales,
then the mathematical equations governing universal expansion change entirely. The accelerated expansion wouldn't require a phantom dark energy pushing galaxies apart.
it would just be the natural result of a modified theory of gravity acting over vast distances.
Exactly. We might not need to discover a new substance. We might just need to correct the rules we thought we already understood.
That perfectly underscores a vital point made at the Congress by philosopher Barry Lower from Rutgers University.
Yes, his point on intuition.
He pointed out that our intuition, our innate gut feeling about how physics, space, and time ought to operate, only gets us so far.
And there is a brutally logical evolutionary reason for that limitation.
Right. Our intuition evolved for a highly specific purpose, to help us survive on the surface of a rocky planet, not to understand the underlying mechanics of the cosmos.
Our brains are biologically wired to calculate the trajectory of a thrown rock, track a predator moving through the brush, or judge the velocity of a river.
They are absolutely not wired to comprehend the geometry of curved space-time.
Or a particle existing in a state of quantum superposition.
No. Therefore, according to Lower, the actual primary job of science is to rigorously explain why our intuition consistently fails us when we look at the universe.
If we connect this to the bigger picture, Lower's point is actually a testament to human resilience.
Yeah.
Yes, our perceptual equipment is fundamentally utilitarian, built purely for basic survival. We are essentially primates operating with a slightly upgraded cognitive system.
Just monkeys with calculators, basically.
Basically. Yet, despite those profound biological limitations, we have developed the capacity to look up at the night sky, question the origins of the Big Bang, and formulate staggeringly complex mathematical frameworks to test those questions.
That is pretty amazing.
The ability to recognize and calculate the boundaries of our own intuition is an absolute triumph of the human intellect.
It is a triumph, absolutely. But it also introduces a highly problematic bias into our data, which is where the tone of the Congress discussions shifted into deeper philosophical waters.
Right, the bias of existence.
Exactly. If our perception is strictly tuned for our survival, how much is our very existence skewing the data we collect about reality? We understand how we perceive, but what does our mere ability to exist and perceive actually dictate about the universe we are observing?
This transition from the limits of perception to the bias of existence is a crucial philosophical pivot.
Tell me about James Hartle's warning here.
Right. James Hartle, a deeply respected physicist from the University of California, he introduced a stark, sobering warning at the Congress. I'm going to quote directly from the proceedings here.
Okay.
He stated, "The universe that is most likely to be observed is not necessarily the one that is most likely to exist."
So what does this all mean? Let's apply a survival bias analogy here. Imagine you are conducting an interview with someone who just won a massive multi-billion-dollar lottery.
Okay, I'm picturing it.
He is standing there holding the giant novelty check. To his personal lived experience, winning the lottery is a concrete reality. Now, if he assumes that winning the lottery is a standard, common human experience simply because he had to have won it in order to be standing on that stage giving the interview,
Then he is suffering from a staggering case of survival bias.
he is entirely ignoring the tens of millions of losing tickets because, by definition, he isn't holding one.
That captures the exact phenomenon Hartle is warning the scientific community about, but applied on a cosmic existential scale.
Right.
Our specific universe could very well be the equivalent of that single winning lottery ticket.
Wow.
We look around and observe a finely tuned set of physical laws, laws that permit the formation of stable stars, the synthesis of heavy elements, planetary orbits.
And ultimately, carbon-based life forms capable of hosting a deep dive into cosmology.
Exactly. We observe these rules because we must be in a universe that allows for observers.
Because if we weren't, we wouldn't be here to observe it.
Right. But, as Carlo Rovelli pointed out during the debates, there could be countless other systems or structural realities in the broader universe where the fundamental constants are totally different.
Like what?
Well, he theorized systems where the arrow of time might flow entirely differently, perhaps even in reverse.
But because those systems wouldn't support our biology, we could never evolve there to observe them.
Exactly. Hartle's conclusion is quite grim when you follow the logic all the way down. He states unequivocally that we cannot definitively know if our universe is of a highly unusual, statistically anomalous kind, because, as he puts it, we cannot observe where we cannot exist.
We are permanently stuck in the winner's circle, completely blind to the rest of the stadium.
It demands a radical reevaluation of our most foundational assumptions. It forces the scientific community to question whether our deeply cherished, meticulously calculated laws of physics are truly universal truths that govern all of existence.
Or if they're simply the highly specific, incredibly rare local weather conditions of a single universe that just happens to tolerate human life.
We might be mapping the rules of our specific terrarium and hubristically declaring them the rules of the entire cosmos.
Okay, if your mind isn't spinning yet, let's bring this entirely out of the theoretical realm and much closer to home.
Let's do it.
Because we don't even need to look out into the void of theoretical parallel universes to find the hard limits of our understanding. We can just look at the physical technology right in front of us.
Oh, this is a great point.
The literal device you are using to listen to this audio right now relies on a foundational physical theory that the smartest people in the world openly admit they do not truly comprehend.
We are, of course, talking about quantum mechanics.
Yes, we are.
Shelley Goldstein, a prominent mathematician and physicist at Rutgers, made a point at the Congress that highlights a profound irony in modern science.
Which is?
That quantum mechanics is the undisputed bedrock of modern technology. It's the mathematical foundation of all semiconductors, lasers, and computer processing.
It makes everything we use work.
Exactly. It has been rigorously tested for an entire century and makes incredibly accurate, microscopic predictions. And yet, theoretical physicists remain in fierce, unresolved debate over its deeper meaning. They know the math works, but they do not fundamentally understand the underlying reality of the theory they are applying every single day.
Goldstein summarized this perfectly at the event. He told the room, "If you find what I'm saying strange, it means you understand me."
That's such a brilliant quote.
Isn't it? People dedicate their entire lives to physics, to decode the world, and they end up relying on a primary mathematical tool that remains deeply obscure, almost mystical to the very people using it.
Which brings us to the climax of the Congress's philosophical debate, centered on what David Albert, a philosopher of physics from Columbia, calls the measurement problem.
Okay, lay it on me.
This is where the discipline of philosophy actively has to intervene to help cosmology. According to the foundational equations of quantum mechanics, before you measure a particle at the atomic level, it exists in a state of superposition.
Meaning the math dictates that multiple states or multiple potential realities exist simultaneously.
Right. The equation itself is linear. It smoothly describes a wave of probabilities.
Yes.
Yet our conscious, lived experience of the macro world is strictly singular. When we measure a particle or observe an object, we only ever see one specific, definitive result.
Here's where it gets really interesting. Let's look at the most famous thought experiment in this field. Schrodinger's cat.
Oh, everyone knows Schrodinger's cat.
Right, we all know the basic pop culture setup. The cat in the box is in a superposition, both alive and dead, until observed.
Until you open the box.
But the actual problem physicists are currently debating isn't about the cat at all, is it?
No, it's not.
It's about the observer. Hold on. If you apply the mathematics of quantum mechanics universally, that implies my physical brain is just a highly complex quantum system too, right? Made of the same atoms and particles as the cat.
Exactly the same.
So when I open the box and look inside, am I entering a state of superposition myself?
What's fascinating here is that you have just hit upon the terrifying logical trap that the mathematics sets for us.
Okay, tell me why I'm trapped.
Well, when you open the box, you do get a definitive answer in your conscious experience. But David Albert points out the staggering implication of the Schrödinger equation itself. The equation doesn't contain a built-in mechanism for collapsing the wave of probabilities just because a human looked at it.
Right, it's just math.
If you apply the rules of quantum mechanics to absolutely everything, which logically you must, because the observer's physical brain is governed by the same physics as the experiment.
Then the act of opening the box shouldn't theoretically result in a single definitive answer.
No, it shouldn't.
Because the math says the wave of probabilities just keeps expanding to include the observer.
Precisely. According to the unadulterated theory, when you open the box, the quantum state of your brain becomes entangled with the quantum state of the cat.
Okay.
The raw mathematics predict that at the exact moment of measurement, your physical brain should actually split. Yes. The wave function dictates that there should be one physical brain state that perceives a dead cat, and an equally valid, simultaneously existing physical brain state that perceives a live cat.
But I've opened boxes before. My brain doesn't split. I only ever experience one continuous singular reality.
And that profound disconnect is the measurement problem. Because this conscious splitting demonstrably doesn't happen in our daily lived experience, the scientific community is at a fundamental impasse.
I mean, I would hope my brain isn't splitting.
Right, but the pure mathematics say the universe should be splitting into multiple superimposed realities constantly with every subatomic interaction.
But our conscious experience vehemently insists it doesn't.
Exactly. Physicists and philosophers are frantically trying to identify the hidden physical mechanism that collapses all those mathematical possibilities into the single solid reality you're experiencing right now.
Why does the physical world choose one solution over the other?
We don't know. Albert boldly predicted to the Congress that humanity might actually develop a testable answer to this measurement problem within 25 years.
25 years.
But as of today, it remains a staggering, gaping hole in our foundational understanding of existence.
So let's bring all of these threads together. Science is arguably the most powerful, successful investigative tool humanity has ever devised.
Without a doubt.
It has vastly expanded our perceived reality from a single visible light galaxy to a sprawling cosmos governed by relativity, bizarre atomic behaviors, and the invisible mechanics of dark energy.
But right now, at the absolute frontier of knowledge, it hits a massive wall when faced with the ultimate why.
Why is there a universe instead of a void?
We find our progress hindered by the unattainable data of being trapped within a single universe.
We are limited by a biological intuition built merely for terrestrial survival.
And our mathematical models are heavily biased by the simple, inescapable fact that we must exist in a universe specifically tuned to allow us to observe it.
And if you ever find yourself lying awake, feeling overwhelmed by the sheer, incomprehensible scale of existence,
Or frustrated that you don't grasp how the universe fundamentally operates,
take comfort in this undeniable fact. The digital device you are holding right now operates on the principles of quantum mechanics. It runs on a theory so deeply, fundamentally mysterious that the brilliant minds who engineered it do not fully comprehend what their own equations imply about the nature of reality.
the smartest people on planet Earth are standing right there in the dark with you, trying to figure out the rules of the game.
It is a profoundly shared human condition. We are all, collectively, trying to peer past the physical boundaries of our own perception.
Absolutely.
Which leaves us with one final, lingering question to take with you today. Let's go back to David Albert's terrifying logical conclusion about the mathematics of quantum mechanics.
The splitting brains.
Exactly. If the uncollapsed equations imply that your brain should be splitting every time you perceive a quantum outcome, what if the math is actually right, and your conscious experience is just a localized illusion? What if there is another version of you, created just moments ago by a microscopic quantum measurement in your immediate environment, who is suddenly living out a completely parallel reality, pondering this exact same deep dive?
Well, that raises an important question. Which version of you is the one asking?
Try sleeping on that one tonight.